A massive explosion rips through the heart of deep space, blasting blinding light in every direction across the dark void. A colossal dying star shatters into pieces, shining brighter than billions of normal suns combined. The searing flash travels through the blackness of the cosmos for thousands of years, finally slamming into our planet's atmosphere right this second. Yet nobody with a modern telescope is discovering it for the first time, because human beings carved its exact coordinates into stone thousands of years ago. If you love uncovering the real hidden truths of our universe before the textbooks catch up, hit that subscribe button right now. Join our community of curious minds who seek deep, real space mysteries that challenge what we thought we knew about history. Imagine stepping outside into the quiet night, looking up at the sky, and expecting to see the same familiar constellations you have seen your entire life. You know where the Big Dipper rests, you know where Orion stands, and you trust that the night sky never changes. Then, in the blink of an eye, a brand new point of light appears that shines so intensely bright you can read a book beneath it at midnight. That is the shock that ancient stargazers felt when a giant star ended its life in a violent blast. In modern science, we call this cosmic catastrophe a supernova. It is one of the most violent, energetic events in the entire known universe. When a giant star runs out of nuclear fuel, its core suddenly collapses under its own crushing gravity, triggering an outward blast that unleashes more raw energy in a few weeks than our sun will produce across its entire 10 billion year lifespan. For centuries, modern astronomers believed that detailed, reliable records of the universe only began with the invention of the telescope in the 17th century. They assumed that early humans merely stared at the sky in fearful superstition, telling campfire myths rather than tracking real physical phenomena. Historians long treated ancient rock art and stone carvings as simple artistic symbols or spiritual drawings, with no real connection to actual scientific observations. That comfortable assumption began to fall apart when researchers started re-examining mysterious artifacts scattered across the globe. What they found was not primitive imagination, but rigorous, precise celestial tracking that had been completely overlooked. Ancient civilizations across different continents were systematically recording massive stellar detonations that our best modern satellites are only now beginning to map out with digital sensors. Let us travel back to a remote mountain valley in the Kashmir region of the Indian subcontinent, at an ancient archaeological site known as Burzahama. In the 1960s, archaeologists digging through layers of prehistoric soil unearthed a flat, carved stone slab buried inside the ruins of a dwelling. The slab was dated to roughly 4,500 years ago, placing its creation around 2,600 years before the Common Era. On the surface of this stone, prehistoric artists had carefully etched a detailed scene. It showed a hunt involving a large stag, a hunter holding a bow and arrow, and a dog standing nearby. But carved directly above the animals in the sky area of the rock were two large, distinct, sun-like objects shining side by side. For decades, archaeologists had no idea what to make of these two glowing spheres. The standard scientific theory at the time argued that the artist had simply drawn two suns as a religious symbol, perhaps representing life and death or day and night. Experts claimed prehistoric hunters lacked the tools and mathematical knowledge to record real astronomical coordinates. They assumed the drawing was purely imaginative, a decorative myth etched into rock without any physical basis in reality. Then, an astrophysicist named Mayank Vahia, working at the Tata Institute of Fundamental Research in Mumbai, decided to test this artistic assumption using modern computer modeling. He fed the exact geographic coordinates of the site and the historical positions of the stars, going back thousands of years into an advanced planetarium program. He wanted to see if the night sky over Kashmir ever contained an event that matched the carving. Pay close attention to what the simulation revealed next. Dr. Vahia discovered that the hunting scene was actually an ancient sky map representing constellations. The hunter and the stag matched the exact star patterns of Orion and Taurus as they appeared thousands of years ago. More shockingly, right above Taurus, the computer model pinpointed a massive stellar explosion known today as Supernova remnant HB9, which blew apart around 4,500 years ago. The dying star was located roughly 2,600 light-years away from Earth. When it detonated, the explosion shone with an intense, piercing glow that lasted for months. It was so overwhelmingly luminous that it was easily visible in the broad daylight sky right next to the sun. The ancient artist was not drawing a mythological fantasy. They were faithfully recording the sudden appearance of a daytime supernova in its precise cosmic position. Think about the incredible skill that required. A prehistoric observer, living in an era without metal telescopes or written language, managed to plot the exact location of a temporary star relative to the surrounding celestial figures. They recognized that a brand new object had entered the eternal dance of the cosmos, and they permanently immortalized that rare spectacle on a piece of stone. Did you know that Stone Age humans were capable of creating accurate star maps thousands of years before the telescope was invented? Drop a comment below with your thoughts, and make sure to like the video if discovering this ancient genius gives you chills. This discovery at Burzahama proved that early humans possessed acute observational skills, but it was far from an isolated incident. Across the Pacific Ocean, in the rugged canyons of the American Southwest, another civilization was watching the skies and preparing to leave their own permanent record of a cosmic disaster. In Chaco Canyon, New Mexico, towering sandstone cliffs rise above the desert floor. This area was once the thriving cultural hub of the ancestral Puebloan people, who built massive multi-story stone cities between 900 and 1100 years ago. Underneath a rock overhang along a cliff face, painted in red ochre, sits a famous pictograph that baffled historians for generations. The painting features a clear human handprint next to a large crescent shape, and directly beneath the crescent, an extraordinary 10-pointed star bursting with radiating light. When researchers first discovered the painting in the 20th century, they assumed it was a traditional spiritual emblem. Conventional wisdom stated that the crescent was simply the moon, and the star was either Venus or a generic tribal icon representing the spirit world. Once again, the traditional explanation underestimated the observational power of ancient humans. In the mid-20th century, historians began comparing the date of the Chaco Canyon rock art with famous historical records from the opposite side of the planet. They realized the painting was created during the summer of the year 1054. On July 4th in the year 1054, a giant star 23 times more massive than our sun exploded in the constellation of Taurus, about 6,500 light-years away. Today, the shredded remnants of that star form the famous Crab Nebula, a sprawling cloud of glowing gas expanding outward at millions of miles per hour. But back in 1054, the initial explosion blazed with unbelievable power. Court astronomers working in Song Dynasty China documented the event with meticulous precision. They wrote in imperial scrolls that a guest star appeared in the eastern sky, shining brighter than the planet Venus. Chinese imperial records noted that this guest star was visible in broad daylight for 23 consecutive days, and it remained visible in the dark night sky for nearly 2 full years before fading from human sight. Now, look back at the sandstone cliff in New Mexico. Modern astronomical software reveals that at dawn on July 5th, 1054, as the supernova first climbed into view, the crescent moon passed within just 2 degrees of the exploding star. To someone standing in Chaco Canyon, looking east into the twilight sky, the brilliant exploding star sat exactly underneath the crescent moon, precisely as painted on the canyon wall. The ancestral Puebloan artist had stood outside in the desert chill before dawn, witnessed an unprecedented flash of cosmic light beside the moon, and immediately climbed the cliff face to document the event. They recorded the exact spatial alignment of 2 celestial bodies with stunning photographic accuracy, creating an enduring scientific monument centuries before European astronomers even understood what stars were. This brings us to a crucial realization about ancient science. When modern researchers study the remnants of dead stars, they often face a massive obstacle: time. A supernova explosion happens in a matter of seconds, but the expanding debris cloud takes tens of thousands of years to grow and cool down. Modern telescopes can only capture a tiny snapshot of that expansion over a few decades of recent observations. To calculate how fast a nebula is expanding and to accurately measure its original energy, scientists need a firm starting date. They need to know the exact day, month, and year when the explosion first became visible from Earth. Without historical human records, scientists are forced to guess the age of a remnant using mathematical estimates that can be off by thousands of years. Ancient records act as an irreplaceable time machine for modern astrophysics. By matching the precise descriptions written by ancient Chinese stargazers or painted by Native American observers with the gas clouds we see today, astronomers can calculate the exact speed of the explosion over a span of 1,000 years. Ancient people provided the crucial baseline data that modern supercomputers require to unlock the physics of stellar death. Does it blow your mind that modern astrophysicists rely on ancient tribal paintings to verify their space data? If you find this connection between ancient history and modern space science fascinating, subscribe right now and tap the bell icon so you never miss another deep investigation. The story gets even stranger when we examine the mysterious silence of medieval Europe during these same cosmic events. When the supernova of 1054 blazed across the heavens, shining brightly enough to cast shadows on the ground at night, almost no surviving European manuscripts wrote a single word about it. For centuries, this complete lack of European documentation was a total puzzle. Scientists originally thought that chronic bad weather and heavy cloud cover across Europe must have blocked the view for those 23 days of daylight visibility. It seemed impossible that an entire continent of people could fail to notice a blazing light in the sky that outshone every other star and planet. However, historians later discovered that the silence was not caused by bad weather, but by strict religious dogma. During the Middle Ages in Europe, Mainstream philosophical thought was heavily dominated by the ancient Greek ideas of Aristotle, which had been merged into official church doctrine. Aristotelian cosmology taught that the heavens were perfect, unchanging, and eternally static, created by the divine in an unalterable state. To admit that a brand new star had suddenly appeared in the pristine heavens would mean acknowledging that the universe was changing, decaying, and violent. Writing down that a new star was shining in the sky was considered dangerous heresy that challenged the fundamental worldview of the establishment. As a result, the exploding star was ignored, scrubbed from records, or explained away as an atmospheric illusion rather than a celestial reality. Yet, outside of dogmatic control, other cultures recorded the truth without fear. In the Islamic world, where astronomy and mathematics were flourishing during the Golden Age, scholars did not hide from the evidence in the sky. In the city of Baghdad, a famous Christian Arab physician and scholar named Ibn Butlan explicitly documented the brilliant new star in his medical and astronomical journals, noting how its light coincided with seasonal epidemics and atmospheric changes. This stark contrast reveals a profound truth about science. Having eyes to see the universe is not enough. A society must also have the open-mindedness to accept what nature reveals. While some cultures closed their eyes to maintain comfortable traditions, others faithfully recorded the truth, preserving vital scientific knowledge for future generations. Now, let us examine an even older and far more mysterious case that takes us back nearly 2,000 years, to the very dawn of written supernova observations. In the year 185 of the Common Era, during the Han Dynasty in ancient China, court astrologers looking toward the southern constellation of Centaurus saw a sparkling visitor emerge from the darkness. The ancient text, preserved in the Book of the Later Han, described the object as a star as large as a bamboo mat that displayed 5 distinct colors. It danced and flickered in the southern sky for over 8 months before gradually fading into darkness. This text represents the oldest confirmed written record of a supernova in human history, officially designated by modern astronomers as Supernova 185. For nearly 2 millennia, the true physical location of this ancient blast remained an unsolved mystery. Astronomers knew the general region of the sky where the Chinese court observed the star, but they could not find the exact cosmic debris cloud left behind. Many scientists wondered if the ancient record was an exaggeration, perhaps a passing comet with a colorful tail, rather than an actual dying star. The definitive proof finally arrived when NASA launched the Chandra X-ray Observatory and the Spitzer Space Telescope into orbit. In 2006, astronomers pointed these advanced infrared and X-ray instruments toward the constellation Circinus, near the stars described in the Han Dynasty scrolls. What they uncovered in the dark void shocked the astronomical community. Tucked within the interstellar dust was a vast, glowing bubble of superheated gas known as RCW-86, measuring over 85 light-years across. When scientists analyzed the X-ray emissions coming from the shell, they realized the gas was moving at an astounding speed of over 6 million miles per hour. By calculating the expansion rate backwards, the team determined that the bubble started expanding precisely 1,800 years ago. The math locked into place with absolute perfection. The radioactive bubble of gas mapped by high-tech space telescopes was the exact same object that Chinese astronomers watched with their naked eyes in the year 185. A forgotten explosion from the ancient world was suddenly verified by the most sophisticated instruments in modern science. The data revealed something even more dramatic about how this particular star died. Supernova 185 was not an ordinary core collapse explosion. It was a rare and catastrophic event called a Type 1a supernova. This happens when a dead, ultra-dense white dwarf star feeds on gas from a neighboring companion star, growing heavier and heavier until it reaches a critical mass and detonates in a thermonuclear blast. The explosion carved out a massive hollow cavity in the surrounding interstellar gas, allowing the shock wave to race outward much faster than normal. That is why the ancient Chinese observers saw it expand into an enormous multicolored disk the size of a bamboo mat. The precise descriptive words written with brush and ink in ancient China match the exact thermal dynamics of a white dwarf thermonuclear detonation. How remarkable is it that simple scrolls written nearly 2,000 years ago accurately describe the physical behavior of a thermonuclear blast in deep space? Share your reaction in the comments below, and give this video a thumbs up to support uncovering more lost scientific history. As scientists continued connecting historical records to deep space objects, they stumbled upon another mind-bending puzzle from the year 1006. In that year, the brightest stellar event in recorded human history illuminated the Earth. Observers from China, Japan, Egypt, Iraq, Italy, and Switzerland all documented an incomprehensibly bright star appearing in the constellation Lupus. An Egyptian astronomer named Ali ibn Ridwan wrote that the new star was nearly 3 times wider than the planet Venus, and shone with a brightness equivalent to 1/4 of the light of the full moon. People were able to clearly navigate city streets at night under its cold, silvery glare. The object was so intensely luminous that it remained visible in the night sky for over 3 years. Modern astrophysicists estimate that supernova 1006 was located about 7,200 light-years from Earth. For an object at that staggering distance to shine with a quarter of the moon's brightness, the physical energy released during the initial explosion must have been almost unimaginable. It released more light and radiation than the combined output of several 100 million stars. Yet, despite its overwhelming visibility across the globe, astronomers could not find any visible trace of a remnant star or compact core left behind at that location. When modern optical telescopes looked at the coordinates where the supernova blazed, they saw nothing but empty, dark space. For decades, scientists were baffled by the complete absence of a central neutron star or black hole. The mystery was finally solved using sensitive radio telescopes and deep space imaging. The explosion was so completely destructive that the entire progenitor star was obliterated down to its last atom. There was no core left behind, no dense ember, and no surviving remnant body. The entire white dwarf star converted its mass directly into pure expanding energy, leaving only an invisible glowing shockwave echoing through space. Ancient observers had documented the total annihilation of an entire stellar system. Their descriptions of the star's sudden peak brightness and gradual multi-year fading provided modern scientists with the ultimate textbook example of a pure thermonuclear runaway explosion. Without the global eyewitness testimonies from the year 1006, we would never have understood the full timeline of this total stellar destruction. Another extraordinary historical record surfaced in the late 16th century, right on the threshold of the scientific revolution. In November of the year 1572, a Danish nobleman and astronomer named Tycho Brahe stepped out of his laboratory and looked up into the constellation Cassiopeia. To his absolute astonishment, he saw a brilliant point of light that had never been there before. Tycho Brahe was a master of precision. Using specially designed measuring instruments called sextants and quadrants, he tracked the exact angular position of this new star night after night for over a year. He wanted to prove whether the object was close to Earth, like a cloud or a comet in the upper atmosphere, or far away among the distant stars. If the object were close to Earth, its position against the background stars would shift depending on the observer's viewing angle, an effect called parallax. But Tycho Brahe proved that the new star did not move at all relative to the background constellations. It had zero detectable parallax, which meant it had to be located far beyond the moon, deep in the supposedly unchangeable sphere of the distant stars. Tycho published his findings in a revolutionary book titled On the New Star, coining the Latin word nova, which means new. His precise measurements completely shattered the ancient Greek belief in a static, unalterable universe, paving the way for modern astronomy. Centuries later, modern X-ray space telescopes confirmed that Tycho's supernova was another massive Type 1a thermonuclear blast located over 8,000 light-years from our planet. Just 32 years later, in the year 1604, another brilliant explosion lit up the heavens. This time, it was observed and carefully recorded by Johannes Kepler, a brilliant German mathematician and astronomer who was working as the imperial mathematician in Prague. Kepler tracked the new star in the constellation Ophiuchus for an entire year. Kepler's supernova holds a special haunting title in the history of astronomy. It is the very last supernova ever observed with the naked eye inside our own Milky Way galaxy. For over 400 years since 1604, our galaxy has remained eerily quiet, with not a single visible supernova bursting into view within our local stellar neighborhood. Have you ever stopped to wonder how different human history would be if telescopes were invented just a few decades earlier? If you find yourself lost in these historical mysteries, tap that subscribe button and give us a thumbs up so we can bring you more untold stories of our cosmos. The historical records of these explosions do not just tell us about the past, they help scientists solve one of the greatest riddles of chemistry. Where did the matter that makes up our world actually come from? When the universe began during the Big Bang, only the simplest, lightest elements were created, mostly hydrogen and helium, with tiny traces of lithium. There was no carbon for organic life, no oxygen to breathe, and no iron for rocky planets. Stars act as massive nuclear fusion engines, fusing hydrogen into helium, and then fusing helium into heavier elements like carbon, nitrogen, and oxygen inside their fiery cores. But normal stellar fusion stops when a star's core turns into solid iron. Fusing iron does not produce energy, it absorbs energy, causing the core to instantly lose the outward pressure supporting its massive weight. When the core collapses, the outer layers crash inward at a quarter of the speed of light before rebounding in a catastrophic shockwave. In that violent split-second explosion, temperatures soar to billions of degrees, unleashing an intense flood of free neutrons. This extreme environment triggers what scientists call explosive nucleosynthesis, creating the heaviest elements on the periodic table, including gold, platinum, silver, copper, and uranium. The exploding star then flings these precious heavy elements across thousands of light years of space, seeding cold, dark gas clouds with the raw building blocks of future solar systems. Every single atom of iron in the red hemoglobin of your blood, every particle of calcium in your teeth and bones, and every fleck of gold in a wedding band was literally cooked inside the heart of an ancient dying star and blasted across the galaxy in a supernova. When ancient humans stood under the dark night sky and carved pictures of exploding stars into rock, they were unknowingly looking at the cosmic factories that forged their own physical bodies. They were made of the very dust that supernovas scattered across the void billions of years ago. In the most literal scientific sense, when humans study supernovas, we are stardust studying the death of stars. To make this mystery even more fascinating, modern geologists have started finding direct physical traces of ancient supernovas right beneath our feet on planet Earth. When a giant star explodes within a few hundred light years of our solar system, its high-energy shockwave sweeps across interplanetary space, raining down rare radioactive isotopes directly onto Earth's atmosphere and oceans. One of the most telling isotopes is an extremely rare form of iron known as iron-60. Unlike the stable iron found in normal rocks, iron-60 is not naturally produced on Earth because it decays radioactive over millions of years. The only place iron-60 can possibly be created is inside the crushing, high-temperature crucible of a massive supernova explosion right before it detonates. In the late 1990s, German scientists drilling deep into the ocean floor of the Pacific brought up core samples of ancient sediment and manganese crusts. When they ran these samples through powerful mass spectrometers, they detected unmistakable spikes of iron-60 buried in sediment layers that formed between 2 and 3 million years ago. This physical evidence proved beyond any doubt that a massive star exploded uncomfortably close to Earth, roughly 300 light years away. Around the same time, our early human ancestors were first learning to walk upright. The radioactive fallout from that ancient explosion settled quietly onto the oceans and was locked into stone for millions of years, waiting for modern geologists to dig it up. What makes this finding so chilling is how closely it matches changes in Earth's ancient climate. When that supernova bathed our upper atmosphere in cosmic rays millions of years ago, it increased cloud cover, stripped parts of the ozone shield, and triggered global cooling trends that helped reshape prehistoric life. The death of distant stars has actively altered the evolutionary path of our own planet. Have you ever imagined that the dust of an exploding star might be buried deep beneath the ocean floor, right beneath where you live? If learning about how cosmic explosions shaped our planet fascinates you, share this video with someone who loves deep Earth discoveries, and remember to subscribe for more hidden scientific breakthroughs. This brings us to a compelling shift in how we understand our ongoing relationship with the cosmos. These ancient recordings are not just historical curiosities from a dead past. The exact physical processes that illuminated the skies over ancient Kashmir, Chaco Canyon, and imperial China are happening right now across our galaxy, and they pose real, active questions for the future of humanity. Within our own Milky Way galaxy, giant stars are currently teetering on the edge of death. One of the most famous candidates is the red supergiant star Betelgeuse, located in the shoulder of Orion, roughly 650 light years away from Earth. Betelgeuse is so colossal that if you placed it at the center of our solar system, its outer surface would extend past the orbit of Mars and approach the orbit of Jupiter. In recent years, Betelgeuse has exhibited strange, unpredictable dimming and brightening behavior that caught the attention of astronomers worldwide. Giant clouds of dust were ejected from its surface as its core convulsed, signaling that the star is nearing the absolute end of its nuclear fuel supply. When Betelgeuse finally runs out of fuel, it will collapse and explode in a supernova of epic proportions. When that happens, the sky over Earth will experience a spectacle unlike anything seen since the year 1006. The explosion will shine with the brilliance of a full moon, visible in broad daylight for months on end. People all over the world will look up and witness a blinding flash of cosmic destruction with their naked eyes, just as our ancient ancestors did thousands of years ago. Fortunately, at a distance of over 600 light years, Betelgeuse is safely outside the danger zone for life on Earth. Scientists calculate that a supernova would need to occur within roughly 30 to 50 light years of our planet for its deadly gamma rays and high-energy cosmic radiation to strip away our protective ozone layer and cause mass extinction. However, the real cosmic question is not whether a nearby star will explode, but when. Massive stars, like Eta Carinae, located about 7,500 light years away, are unstable hypergiants over 100 times more massive than our Sun. Eta Carinae is so violently unstable that it is expected to explode as a hypernova, a blast up to 100 times more powerful than a standard supernova, releasing massive energy jets across deep space. Think about the profound connection this creates between past, present, and future. When ancient humans stood beneath the open sky, they had no metal rockets, no satellite telescopes, and no digital sensors. Yet, they possessed an innate curiosity and a deep drive to understand the universe around them. They looked at the cosmos, not with apathy, but with awe, recording its wonders on cave walls, stone slabs, and parchment scrolls. They preserved the memory of vanishing cosmic events so that we, thousands of years later, could look through our telescopes and complete the story they began. They remind us that the human desire to explore, document, and make sense of the vast unknown is one of the oldest and most fundamental traits of our species. We are the inheritors of their ancient curiosity, continuing their timeless quest to understand the stars. Every time we discover an ancient carving of an exploding star or decode a lost celestial scroll, we are reminded that we are not separate from the cosmos. We are made of the very same stardust that was forged in ancient stellar explosions billions of years ago. The calcium in our bones, the iron in our blood, and the oxygen we breathe were all blasted across space by ancient supernovas before our solar system even formed. When we study these historical cosmic catastrophes, we are literally using stardust to study the death of stars. We are the universe observing itself, trying to understand where we came from and where we are going. The ancient stone carvers knew that the lights in the sky held the deepest secrets of reality, and their stone records still speak to us across thousands of years of human history. If you enjoyed journeying into this lost connection between ancient civilizations and the violent physics of our universe, please subscribe to the channel, click that notification bell, and leave a comment below sharing which ancient supernova discovery surprised you the most. Do not forget to share this video with a friend or a family member who loves deep space mysteries and ancient history. Thank you so much for watching, and stay endlessly curious about the secrets written across the night sky.